Integration by partial fraction case 3, there are irreducible quadratic factors in the denominator, and the quadratic factors have no repetition. If you take a look at the red integral, there are no factors yet. So the reason I picked this problem is because I want to review how to factor by groups. So when you see four terms, the only way to do the factor is you do factor by groups. So you group the first two terms, the two terms with the highest power, and the last two terms. So for the first two terms, I'm going to factor out x squared. So you have x plus 1. And then the second parenthesis, nothing, just write a 1 in there, and then x plus 1. So now you factor out x plus 1, and then you have x squared plus 1. And the x squared plus 1 cannot be factored. It is quadratic due to the second degree, and it is not repeated, so that fits into case 3. Okay, so let's put this up. So we have integral 4x divided by x plus 1 times x squared plus 1. So the x squared plus 1 is quadratic, no repetition, and it is irreducible because a squared plus b squared cannot be factored. And this is a dx, and then we prepare the two fractions. So we have 4x divided by x plus 1 times x squared plus 1. So for the x plus 1, we use one letter for that because that is a linear. And then for the x squared plus 1, we use two letters for that, bx plus c. Okay, and then we find the common denominator. 4x is equals to a. I am looking for x squared plus 1. And then the bx plus c, I am looking for x plus 1. Okay, so this one you can use convenient number by simply let x equals to -1. So this will find the a for you. So when x is equals to -1, -1 times 4, that is equals to -4, and then the x equals to -1, get rid of the bx plus c, right? So you have you have 1 plus 1, so that will be a 2a. So that a is equals to -2. So that is for convenient number. And then that's all we can do. The x squared plus 1 is a parabola, shift 1 unit up that never go across the x-axis. So the x squared plus 1 will never equal to 0. You square a number, you add 1 to it, you will never get a 0. Okay, so for the rest, we have to go to the system. So 4x, let's stick with the red. So 4x, that is equals to ax squared plus a, and then plus bx squared plus bx plus cx plus 1. And then you group all the x terms together, right? So 4a, where are the x squared? So we have the square, we have the square, and then we have the first power, the first power, and the first power, and the 1, right? Okay, let's group them. So we factor out the x squared, so we have a plus b inside the parenthesis, and then the first power, we factor out the x, so we have b plus c, and then the constant, we have a plus 1. So the 4a, why do I put a 4a? That is supposed to be a 4x. So that is supposed to be a 4x, so let's fix that to a 4x. 4x, so this is a 4x. All right, there is no x squared on the other side, so we do a 0x squared plus 4x plus 0. How's that? So the 0 will match to the a plus b, and then the 4 will match to the b plus c, and then the 0 will match to a plus 1. We should do that in another color. So the 4 matches to b plus c, and then the 0 will match to a plus 1. All right, equate the coefficient. So equating coefficient, we have a system, right? So a plus b is equals to 0. So we have a plus b equals to 0, b plus c equals to 4, and a plus 1 is equal to 0. So this is my system. So when a equals to -2, a plus 1 or a plus c. Mistake here. C times 1, that is supposed to be c, that is supposed to be c. So a plus c is equals to 0. So now when I plug in my a, -2 plus c equals to 0, c is equals to 2. So now I got my a and I got my c. So since c is equals to 2, then 2 plus c equals to 4. C is equals to 2. I'm trying to solve for b. So b plus 2 equals to 4. B is equals to 2. And then we have a, b, and c. Oh, done. We got a, b, and c. All right then. So the next step is we go back to the integration. So we have the integral of a is equals to -2 divided by x plus 1, and then dx, and then plus bx plus c, so that will be 2x plus 2 divided by x squared plus 1 dx. So the first integral gives me an ln, right? So this integral gives me a -2 ln absolute value of x plus 1. And then the other integral, we have to break this down into two integrals, 2x divided by x squared plus 1, and then 2 divided by x squared plus 1. So for the x squared plus 1, you can use u substitution. U equals to x squared plus 1. Du is equals to 2x dx. And the entire numerator will be cancelled. So overall, the first one, so we'll bring this one down here, -2 ln absolute value of x plus 1. And then the next one is ln parenthesis x squared plus 1. Because x squared plus 1 is always positive. By the way, after you cancel out the 2x, you only have integral of 1 over u du. That's how I got the ln. And then the third one, the last one, let's put that in a different color. So this one in yellow. So this one you have to recall a formula. An integration formula. The integration formula is the integral of 1 divided by x squared plus a squared dx equals to 1 divided by a, and then inverse tangent x divided by a plus c. So in here we have a equals to 1. So the way we write this is we write the 2 first. So we write the 2 first. So the 2 and then 1 over a, right? So that will be 1 over 1. And then inverse tangent x over 1 plus c. So if you get rid of the 1, then that will be the final answer. So the final answer is right over here. Alright, so that is the end of this problem and this video. If you think I picked the best problem, my explanation is clear, give me a like, let me know in the comment below, subscribe to my channel, share the video for me. Appreciate your help. See you all in the next one. Signing off for now.